dear students, welcome to this video tutorial. Today we are going to read one of the easiest and very important as well, one of the easiest topic and very important topic as well of class 9 of compulsory mathematics. That is, I have written on the board laws of indices. And my dear students, I must remind you something about laws of indices. You might have read from class 7, 8 also. I am 100% sure most of you have learnt about laws of indices in class 7 and 8. So today we are not going to talk much about this. Today we are going to talk about laws of indices, and you know very well math is all about practice, and for practice you must know the concept before you solve. So today let us talk about the main concept of using laws of indices. So I have written some laws of indices on the board. About most of the laws you might have read in your previous classes. So today let us start from the simplest law, that is, we say here I have written a to the power 0 equals to 1. But before that, it's not necessary to tell about this. If I do write one algebraic expression 3x to the power 4, if 3 represents here coefficient, x represents base, and 4 represents power. That we say index as well, and plural form of index is indices. And anything, any letter having whole power 0, the value is always 1. That is called law of zero index. Here having a to the power 0 also gives the value 1. X to the power 0 also gives the value 1. Anything, any letter having whole power 0 gives the value always 1. That is called law of zero index. It means 7 to the power 0 also equals to 1. 4x whole power 0, that is also equals to 1. 7 upon 8 whole power 0, that is also equals to 1. And so on. Then we are not going to talk much about the first law because this is the simplest law, you know very well. You have just checked the power. If the power of anything, any letter is 0 or index 0, the value is always 1. It's the law of zero index. Then second, we say a to the power m. Here a represents base, m represents power or index. Here again a represents base, m represents power. Here you can do easily see. You can easily do understand. Here a represents base and here also a represents base. It means the bases are same here. Bases are same. Then in multiplication, if the bases are same, writing a single base, we add the powers. It is called product law of index. Or you can say simply multiplication law of index also, no problem. But we say product law of index. It means simply you can say as the base, if the bases are same, writing a single base, we add the powers. We add the powers if the bases are same, writing a single base in multiplication. Simply insert. In multiplication we add the powers. So this law also we do use while solving short questions along with from this topic the most. Okay, some examples related to base. Don't forget, in multiplication we add the powers. But don't forget, my dear students, there must be same bases. And if we have multiplication relation, by the time we can use the product of index, that is in multiplication we have the powers. A very simple example, if we have, you read already in your previous class, x to the power 4 times x to the power 7. Here, x represents base, 4 index, x base, 7 index of power. You can see here, clearly see here, the bases are same. And if the bases are same, here is the case of multiplication. So, if with the bases are same in multiplication, we add the powers. That is writing a single base, that is x. We add the powers. 4 plus 7. 4 plus 7, that is x to the power 11. You can derive it wrong in the third step also, no problem. X to the power 4 plus 7, 11. Okay, similarly this law also we use the most while solving problems related to laws of indices. One more example, if we do have this type, x to the power a plus b times again x to the power b plus c, this type. Again to check. What is the base here? X. Power a plus b or index. Similar, the next base we have x. Now, the bases are again same. What is the relation? Multiplication. In multiplication, we add the powers. X same. A plus b. Here, the first power is a plus b. Then we have the rule. Powers are added. Plus the second power b plus c. It is x to the power. The first power a plus b, second power b plus c. Then, let us add the powers. A does not have any like term. Again, it means you plus b and plus b. These two are the like terms. These two can be simplified. X to the power a plus b plus b to b plus c. We don't have any other like terms. It will be x to the power a plus 2b plus c. Is the required answer for this. It means the main thing you should know in multiplication we have the powers. So while solving some questions, some short questions or long questions related to this topic, we shall talk much about this again. But let's start the second one. But you are the class 9. Now as we know, x to the, so a to the power m times a to the power n equals to a to the power m plus n. This is product of index. But you have to know, you are this class 9 by another idea also. So we know a to the power x times a to the power y, that is equals to the power x plus y. If we have this type of question, this can be simplified by this way. Writing a single base a, we add the powers x plus y, a to the power x plus y. But while solving some questions, this can be broken to this type also. That is, if we do have x to the power c plus d, it can be broken as here the powers have added. That is, it can be broken x to the power c times x to the power d. I mean, it can be broken, it can be written in this form also. Because you can check also. Here x same base, writing a single base x, the powers c and d can be added. So this can be simplified by this, or this can be simplified or can be written into this form also. Okay, we shall talk again about this while solving some short time question or some long time question. Then let's talk the third law. If you have understood product law of index, division law of index, you can do it. In fact, only one thing is different. Then a same base. If the bases are same in division, we subtract the powers. We subtract the powers in division. I mean, if the base, but don't forget my students, there must be same base, then only this law also can be used. If the bases are same, writing a single base, we subtract the powers in division. In division, we subtract the powers. This is the main thing. Okay, so one example of this, if we do have x to the power 7 divided by x to the power 3. Here, x is base. In the second expression also, x is the base. Here is the division relation. As we know, in division we subtract the powers, but there must be same bases. As x and x are same, writing a single base, here is the power 7. As we have the condition of division here, using the rule, in division we subtract the powers. 7 minus the second power 3, x to the power 7 minus 3, 4. And this in division we subtract the powers. But here this can be written by this way. By this way also, these two are same. But here also we have a to the power n divided by a to the power n. Here is the case of division. But in division is so a to the power n divided by a to the power n. Here is also the case of division. So writing a single base a, we subtract the powers. This is the third law, we say division law of index. Next we have fourth law, power law of index. Here a represents base, m represents power, and we have the whole power n. That means a to the power n whole power n. If we have the condition of whole power, powers are multiplied, or we multiply the powers. It's called power of index. As m and n are the both powers, powers are multiplied. A same. If we multiply m and n, that gives mn. It's called power of index. This also we use the most while solving the short time question the most. Okay, a to the power m whole power n, that is a to the power n. Okay, one example of this. x to the power 3 whole power 2. And this type of problem you read already in the previous classes. Here ax is the base 3 power and it has again whole power 2. That means using power of index, as you know, powers are multiplied. This is x same 3 times 2 6. We got x to the power 6 by multiplying the powers. 3 2 the 6. That is powers are multiplied. Okay, this law also is the most while solving questions. One more example, x to the power a minus b whole power, we do have 2. Okay, let's try the option. We know powers are multiplied. That is 2 times of a, 2 times a, 2a minus 2 times b to b. By this way we use power of index. But this law, okay, sometimes we may have the question in this format also. So if we have x to the x by y whole power 3. This is the power of x also, this is the power of y also. Here also, this can be simplified using power of index. Now you can see if x has no power inside them. And if x has the power 1, y has also the power 1. Using power of index, x to the power 3 1s are. Do consider 3 1s are 3. And y to the power here 1. So that is 3 1s are again y to the power 3. So if we have the question given in this format, we can use power of index by this way, and we can simplify by using power of index by this way. Similarly, I have written the next condition a b whole power 3. Let me see here also this if the question has taken this form, I mean if the question is given by this way, this, okay, as a has no power, we say a has the power 1, b has also the power 1. That is using power of a same 3 1s are 3, b same 3 1s are 3. It can be simplified by this way. Or again, you are listening to class 9. You have to know by another idea also. You see here, a to the power 4 times b to the power 4. A and b have same powers. A has the power 4, b has also the power 4. It can be written into single power also. That is a to the power 4 times b to the power 4. It can be written into this form. Similarly, again, 2 more examples here. So if we have 3 to the power 4 divided by 5 to the power 4. Here again you can see 3 has the power 4, 5 has also the power 4. 3 and 4 have equal powers. That as 3 and 5 have equal powers, this can be, we can express it into single power also. 3 by 5 all to the power 4. And then you can do check also. Using power of index, this can be simplified to this type also. 3 to the power 4 upon 5 to the power 4. And sometimes if we do have this type, 7 to the power x times 8 to the power x. That means 7 and 8 have same powers. Can be written into single power, 7 times 8 whole power x. Be careful my dear students, you whole power of index also we use the most while solving the problems. Similarly, the next, we do have a to the power minus m equals to 1 by a to the power m. It means this we say law of negative index. Here a represents base, m represents power. Now you know very well m minus m, it has negative power. Now we know very well 2 to the power 2. And it is 2 times 2, that is equals to 4. If 3 is square, that means 3 times 3, that is 9. And I want to tell you one thing. If we do have positive power, it's very simple to calculate the value. If we do have positive power, it's very simple to calculate the value. If we have 2 to the power minus 2, it's a little difficult. So while solving this type of problem, while solving this type of problem, we use law of negative index. That is a has power minus m. That means a has the power m. So while calculating the value of this type, we must change negative power into positive power. So to make negative power here, it's given in the numerator. Here, it has no denominator. It means 1 can be written. So a has negative power. It is given upside. So to make the power of a positive, it should be taken down. Then a to the power. If we take a to the power minus m down, it becomes a to the power plus m. The power was negative. When you take it down, the power becomes positive. Upside, nothing left. We write 1. Similarly, while using law of negative index, we can use another idea also. I hope some of you might have not read this concept. I have written a by b whole power minus 3. Here, the base is a by b whole power minus 3. The power is negative over here. We have direct idea to change negative power into positive power. So here, a by b whole to the power minus 3. It can be simplified by this way. So, a by b, the power was negative. It can be simplified by this way. A by b. It means a by b, its reciprocal is written b by a. It means we interchange numerator and denominator just to make the power positive. So a by b now change into b by a. Power was minus 3. Now power became plus 3. It is a by b whole to the power minus 3 equals to b by a whole to the power plus 3. If I do solve it by giving one more example, it will be better, my dear students. It can be verified by this way. A to the power a by b whole power, let us consider minus 4. We have the idea a by b whole power minus 4 can be changed, the power can be changed to positive directly by writing reciprocal of it, b up, a down. Then power was negative, now power positive. This is the idea. You can use this law directly, but I just want to tell you why b by a. If you add b by a, why the power minus 2 becomes plus 4? Okay, let us use power of a to the power. Here, the power of a is plus 1. So, using power of index, minus 4 into plus 1 gives minus 4. b to the power, again b have the power 1 inside. So 1 minus 4 into 1 gives minus 4. Okay, a to the power minus 4, b to the power minus 4. A and b have both negative powers. Both have negative powers. So let us take it down. Why? To make the power of a positive. Let us take b to the power minus 4 up to make the power of b positive. Okay, if we take b to the power minus 4 up, it becomes b to the power minus 4 becomes plus 4. Similarly, when you take a to the power minus 4 down, it becomes a to the power minus 4 changes into plus 4. Similarly, b and a have equal powers, can be written into single power, b by a whole power 4. So these two steps not necessary, you can do them directly into this step. What is the main concept? Just write the reciprocal of the base. A by b, just write b by a and change the sign of power. And one more thing, some of you may get some confusion over here. Only one thing, just change the base. Write the reciprocal of this and just change the sign of power only. Don't change the sign of base. Just change the sign of power. But you are from class 9. You must know. If x by y whole power 4. If we add y by x, what has happened over here? We have written the reciprocal of x by y. That means plus 4. The power was plus 4. It becomes minus 4. This also you should check that. And the last one, we have this, we say root law of index. Here n represents ORD, here order of root. And here a, base a to the power m, we have the order n. It can be simplified. I mean, root can be removed. A, same base. Here the power is m by order. Base same, power by order, then root can be removed. Similarly, this can be written by this way, these two are same. But we don't forget, a to the power, base and power. Order becomes denominator of power. A to the power m by n. A to the power m by n, then root can be removed. So one example of this. So if we do have x3 powers, okay, let us consider 9. Here is the order of this root 3, x3 power 9. Using root law of index, x base same, power 9 by order becomes denominator of power. So one more step, this can be simplified. Don't worry, order becomes denominator of power, the root can be removed. Similarly, this can be simplified, 3 3s are 9. Yes, here is the answer. So my dear students, as I have already told you, mathematics is all about practice. And for practice, you must know the concept. We were talking about the concept of large appendices. Okay. Before we talk the short type of question from this topic, one thing for my dear students, if we do have 25 power 1 by 2. Now if you have understood large appendices, and to make it easier to teach you another period, I am going to solve this 25 to the power 1 by 2. Okay, here, what is the power 1 by 2? What type of power? Negative or positive? Positive. Okay, no problem. If the power is positive, we can do simplify easily. But what type of power is this? Fractional power. If we have fractional power, it's a little difficult to simplify. So we must change the fractional power into whole number power. So to change fractional power into whole number power, we should always try to cancel the denominator of power. What is over here? 2. Sometimes here maybe 3, no problem. Maybe 4, no problem. So we always try to cancel the denominator of power. And the denominator of power, what is here? 2. So let us express base something in square form, let us say. If here be 3, then we express base in cube form. So 25. Do find the prime factors of 25. 5 5 0. It means 25 is equals to 5 times 5. It is actually 5 per square. So it is 25 can be done 5 square. Remember, my dear students, why we are expressing 25 in square form? Because our idea, we always try to cancel the denominator of power. 2. Here is 2. So we are expressing the base in square form. So 5 square whole power 1 by 2. It is 5 square. These 2 can be multiplied using power of index. So 2 times 1 by 2. 2 up and 2 down can be cancelled. Here 5 to the power 1 remaining. 5 to the power 1 is equals to 5. So my dear students, today we talked about the laws of indices and how to use laws of indices. In our next class, we shall touch the, if possible, 2 types of short questions from this topic. So one request from my side, please check one more time. Read the laws of indices and try to do some very easy type of questions by yourself. Remaining in our next class, I must tell you, in our next class we are going to read 2 types of short questions from laws of indices. Thank you, and don't forget to like and subscribe Great TV. Thank you.